Hello all and welcome back to our first lesson of 2021. Hopefully the review went well yesterday. Make sure you're nominating any problems in the forms that are attached to each assignment if you're stuck on anything, because I'd love to help you, and it's really important for me to know where people are getting stuck. So let us keep talking about logarithms from where we left off the week before break. So get yourself ready for notes, and we're going to talk about graphing logarithmic functions. Now, we're going to talk about a basic graph of any logarithm is going to have two basic characteristics. One of which is that it has a vertical asymptote. Now, without any transformations, this vertical asymptote is going to be at x equals 0, is going to be at the y-axis. The next thing is that I'm going to space my graph out a little bit more, make each of these a half instead of 1. So that just makes it a little bit easier to graph on this smaller scale. The next thing is going to be true is that without any transformations, the log is going to have a x-intercept at 1. And what it's going to look like is it's got the asymptote there, and then it's going to go up, and it's going to increase, but it's going to do so slowly. So this is just the generic log base a of x. One thing I think is helpful to notice is that logarithms are the inverses of the exponential functions. So if you remember, exponential had a horizontal asymptote and would go like this. So it's the same shape, it just has the vertical asymptote versus a horizontal asymptote. So here, number 1, find the function of the form y equals log base a of x for the graph. So if I'm looking here, all we need to do is find a, because everything else x and y. So our goal is just to find what value base a is. And you can use guess and check. You can also just use the formula that's given, because we know that if it goes through the point 9, 2, 9 is our x value, 2 is our y value. So we can solve for a by saying 2 is equal to log a of 9. And again, at some point, some of these numbers you'll be able to do in your head very easily. You can also rewrite as exponential. So what this means is that a squared is equal to 9, which means that a is equal to 3. Because we're looking at positives here with log bases. So our function here is the log base 3 of x, because there's no transformations given, though of course all the same rules apply, reflections, translations, anything like that. So an example of that is here, where we have f of x is equal to ln of x minus 2 in parentheses. So what we want to recall from previous chapters is that this is a horizontal shift, and it's going to be a translation 2 spaces to the right. And ln is just a log, so it's going to be the same basic shape. If I am, once again, making my graph, each of these be 1, so that it matches the earlier graph in our notes. Here, we're just going to take the generic graph, which goes through there, and we're going to shift it 2 spaces over, which means that the asymptote is now, instead of being at x equals 0, will be at x equals 2. So here's the new asymptote. And the x-intercept here, instead of being at 1, will be at 3. It hasn't had any reflection, so the basic shape is exactly the same. And this would be our graph of f of x with that single transformation. Please let me know if you have any questions about graphing or about anything from the review, and I look forward to hearing from you soon.